In geotechnical engineering, we study about soil, right? So it's important to understand the soil. If for any foundation you're constructing, you have to understand what type of soil, what is the strength, and accordingly we recommend what type of foundation has to be designed. So there is shallow foundation, okay, and like in foundation, we might have a shallow and deep foundation. So you have isolated footing, you have combined footing. There are also then in deep like a pile foundation. Then so when you're designing this foundation, so you calculate this what is the size of foundation based on the soil parameters. Okay. So now if soil is not of good quality, so we do the soil test. If it is not having enough strength, we try to improve the quality of the soil. Either you remove the soil and replace with good soil, or you may improve the soil by mixing some other additives, okay, some other materials, so that the strength of the soil is increased. So this can be done by uh, proper compaction, by grouting, okay, adding good chemicals inside it to increase the strength. And also water is very much problem if it is there inside the soil. So because compaction you're doing is just to remove the air, and if there is water, there should not be any consolidation for this other for the settlement problem. So you can have proper drainage system so that the water drains out. Okay. So for foundation design, it's important that you look at the soil quality, okay, soil properties, and accordingly, we recommend what type of foundation it has to be. So there is SPC, soil bearing capacity. We calculate, and based on the soil bearing capacity, we know how much area the foundation has to be done. And accordingly, we recommend whether it has to be isolated footing or it has to be combined footing or raft footing. Then we have strip footing, and also or piles. So isolated footing is, so if the area is, so every column has one footing foundation, then it is isolated. So it depends, the area depends on the SPC and how much force it is going to transfer to the soil. Combined footing is like if you have two columns near to each other and each isolated footing is overlapping, you cannot place it, right? So you combine the footing for these two columns or more columns. In case of strip footing, what you do is it's like under the wall. Okay, so under the wall is running around, right? Like a thin strip. For column, you have a dimension like maybe 500 by 500. So you have a size rectangular shape. But for wall, it's like a thin strip running around, right? That's why we have strip footing for under the walls. So if it is 200 mm, so you may have around 500 mm, it's lengthwise it's increasing. Whereas for footings, you may have rectangular or square shape, isolated case or combined case. Then you have raft foot foundation. So depending on how much area more you need, and you may have to full cover the building, the foundation throughout, like below the ground floor slab, you have the full area as foundation. So that is like raft foundation. Okay. So below each column we say as like isolated or you can have combined, and below wall you will have like strip. And if you are full floor below you are having the foundation, it's called as raft foundation. And then you have pile foundation. Normally if the soil is not good and if below layer is good, so you run your foundation till the good layer is there, okay, good layer of soil you get it, so you run like pile foundation. Mm, and there are other mm, way in which you can improve the soil in case, okay, so like you improve it by grouting or you replace the soil with good materials, okay, and you should properly compact it before you start your construction. Okay, so this is about like a foundation um, design, what you're going to do and how soil is important for foundation design. Thank you.